Welcome to my channel Fee Concepts CHM. This is the first part of the series on fluid mechanics, where we will see about steady and turbulent flow and about the equation of continuity. So fluids include both the liquids and the gases. So fluid mechanics is a study of the mechanical properties and the flow properties of fluids. It is a study of fluids in a state of rest or motion. Various applications of fluid mechanics are piping and the ducting network in the ACs, the refrigerator, faucets, vacuum cleaners. We can find the applications of fluid mechanics in these appliances. We can see the application in automobiles also, which involves the transportation of fuel from fuel tank to the cylinder and the mixing of the fuel and the gas. So fluid mechanics, the principles of fluid mechanics helps in the designing of modern engineering systems like aircraft, submarines, boats, rockets, biomedical devices, etc. Steady flow or streamlined flow. We will consider a liquid passing through a glass tube. The velocity v at any point in the liquid does not change with time, both in magnitude and direction. So the velocity is remaining constant at a particular point, even though it may not be the same at all the points, which we can see from this diagram here. At point A, the velocity is v1, at point B, the velocity is v2, but it is remaining constant at this particular points. So if you imagine a particle 1 passing point A with a velocity v1, then it will trace a path A, B, C. Now, any other particle which is following this particle 1 will also follow the same path with the same velocity. So, here the curve ABC is called as a streamline. Two streamlines, they do not intersect, as at the point of intersection the liquid element will have two velocities. The flow is also called as a irrotational flow, as it does not have whirlpools. Turbulent flow, here the velocity at a point changes with time and whirlpools are formed in this case. So different liquid elements will have accelerations, their paths will cross each other, and therefore it will be a disorderly flow. Next is equation of continuity. If a fluid is flowing through a tube, the equation of continuity says that the total mass of the fluid flowing into the tube through any cross section should be equal to the total mass coming out of the same tube from any other cross section in the same time. So we'll consider a pipe of varying cross section. The fluid is flowing at a steady rate, that is, the flow is streamlined. We will consider two cross sections of the tube. So the area of cross section at position 1 we will denote as A1, and at position 2 we will denote as A2. So at position 1 the average speed of the fluid will be V1, area of cross section as we are denoted is A1. At position 2, the average speed of the fluid is taken as V2 and area of cross section is A2. So in a time interval delta t, the fluid crosses a distance which will denote as delta x1 as shown in the diagram. It will be equal to the velocity into time, so that will be v1 into delta t. Now we will write down the volume of the fluid going into the tube through this cross section at position 1. It is, we will have to multiply this distance with area, so a1 into delta x1, so a1 v1 into delta t. Same way we can write down for the another cross section at position 2 at this cross section, that will be a2 v2 into delta t. Now for a streamline flow, the mass of the fluid crossing the cross section area A1 in time delta t will be equal to the mass of fluid crossing the cross section area A2 in time delta t. So the mass that is flowing through this part will be the same as the mass flowing through this part. So we can write down in terms of mass, it will be the density into the volume. Density we are denoting as rho. So density into the volume of this area of volume of the fluid passing through the cross-sectional area at position 1. So rho into A1 into V1 into delta T, that is equal to this density into mass, that will be rho into A2 into V2 into delta T. As the liquids are incompressible, we are taking this density rho at both the positions to be equal. So now we can write down this as A1 V1 into delta T is equal to A2 V2 into delta T. Rho gets cancelled out, or this can be written as A1 V1 is equal to A2 V2. Hence we can write down as AV is equal to a constant. From here what we understand is that this velocity is inversely proportional to the area of cross section. V is inversely proportional to A. That is, the speed of flow through the tube is inversely proportional to area of that particular cross section. A very important equation. So we can write down the equation of continuity. It is a product of the area of cross section and the speed. It remains the same at all points of a tube of flow. This is the equation of continuity. It expresses the law of conservation of mass in fluid dynamics. Thank you for watching this video.